All right, hello, MATH0099. We're continuing today with some review topics, like the cat chased dog the. Well, in English grammar, we're pretty adept to know that this isn't quite a sentence that we can understand. We would probably look for some syntax errors here, like maybe the should be capitalized. Probably the dog, right? Chased, spelling error. The dog chased the cat. So order had to be switched. And then a sentence or a question mark or an exclamation, we'd have some type of punctuation at the end of our sentence. So those rules we've learned over time for English grammar. Now we're going to be learning syntax rules and order rules for our mathematical expressions. We call that order of precedence. Now, precedence, you might think of that let's say, president is on the top level of our hierarchy chart, and then there's a vice president that reports to the president. There might be a couple of directors that report to the vice president. There might be a couple of supervisors that report to each director, and then finally we get down to the workers who report through those channels within a business organization. So precedence, we're looking for who has priority. And an expression like this, we can oftentimes be confused unless there is some order that we all understand and follow. So 16 subtract 6 would be 10 times 2. Does anyone else have a different suggestion for that?
6 times 2.
6 times 2? What's that?
12.
Yeah, and then what?
16.
12, 16 minus 12, right?
Yeah.
What's that answer?
4.
4. Anyone else have a suggestion?
Isn't that how you do it, though?
We'll get there. So, you know, we're pretty sure, but maybe not. So we'll be reviewing our order of precedence. So order of precedence is found on your review pages, number 1 through 25 in your e-text. And there's quite a few topics that are discussed there. It's chapters 1 through maybe 3 or 4 even in prep with topics for review. So you might want to look at that. Our rules of precedence then, please excuse my dear Aunt Sally. That's kind of our crib sheet, our notes. Please stands for our parentheses. Please stands for parentheses. Maybe angle brackets, maybe braces. Where there's one opening parenthesis, there's a matching closed parenthesis. Priority, please, parentheses, have priority. And then excuse, please excuse. Excuse stands for exponents. We follow with my dear. My stands for multiplication. Dear stands for division. And just remember, that's from left to right in your expression. So if you have multiplication and division, you're going to move from left to right in your expression to solve. Aunt Sally, aunt stands for addition and subtraction. From left to right. So as you move from left to right in your expression, that's how we solve. So looking at our example, we have no parentheses, so I can scratch that off. There were no exponents in this expression. I had multiplication. So from left to right, there's multiplication. And I know that the operator operates on two operands. 6 times 6 times. Yeah, it's the operand before the operator and the operand after the operator. So multiplication is binary. It takes two numbers. So we know here's the operation of multiplication. It'll be the operator, the number before times the number after. Well, let's see. That'd be 16 subtract 6 times 2 is 12. There's no division, so I can go to my next level, addition and subtraction. There's no addition, but there is subtraction. So I'm going to subtract 12 from 16 and get 4. And that's the order of precedence that we need to remind ourselves. We should know this already, but refresh your memory. And I oftentimes use the little crib sheet note card that condenses the directions, the rules, the steps in your ebook into something we can memorize and make use of. So pages 1 through 25 are your review pages. Okay, on my calculator, I have a TI-84 plus, or maybe a TI-85. Some of you might have that. We had 16 minus 2 times, 16 minus 6 times 2. So I typed in my expression, and your calculator obeys this order of precedence as well. And then at Google, there's a calculator there too. It's not a graphing calculator, but a non-graphing calculator. In your keyword search text box, just type something quick, 5 minus 6. Just some quick expression, and that will resurrect the Google calculator for you. And the Google calculator will suffice for you for this course other than the graphing component. And the graphing component, we have open source free graphing utility that we use, again, via the internet. So you don't really need to buy a calculator for this course. So we've resurrected the Google calculator. You can check for a Google guide or help with the Google calculator or how to use and get some more directions. But for now, I'm just going to clear what was there. And we have the 16 subtract 6 times 2. And sure enough, Google knows the rules of precedence too. So you have those resources to take advantage of. Well, then we've looked at subtraction. A subtract B is equal to A. We define subtraction in terms of addition. So we change subtraction to addition and add the opposite. And now I can add two signed numbers. I know the sign of the number that I'm adding. Otherwise, the sign of the number is tied up or wrapped up within that operation of subtraction. We oftentimes drop a sign, lose a sign, miss a sign. So this is the most important thing you need to correct yourself on if you're making any of those kinds of mistakes. Page 55. The distributive property. The distributive property. A times the quantity, B plus C. Now, if you repeat that to yourself, A times the quantity, doesn't matter how many items are in those parentheses, it's A times everything within the parentheses. Now, the distributive property, how am I going to remember that? Well, when I distribute a quiz to students, I hand out, make sure everyone gets a copy of the quiz. I distribute it. I hand it out to everyone. I don't skip anyone. So we're distributing A times the first term. Oh, that'd be A, B. Pick up your sign and distribute A times the next term. That would be A times C. The distributive property. A times every term within the parentheses. And then we might be able to collect like terms and simplify it from there. That's a distributive property of multiplication over, you see we go over addition. There's also over subtraction. The same thought, I'm going to distribute a quiz to every person in the classroom. I'm not skipping anyone. I'm going to distribute A times the first term, which is AB. Pick up your sign and distribute A times the next term, which is A times C. And a side note to that, we've been saying when you see multiplication or when you see subtraction, be very careful. We can always change subtraction to addition and add the opposite. So I'm going to do that, change subtraction to addition and add the opposite. And I'm doing every single step now, which might be important to you as you kind of get familiar with subtraction and sign control.
You have to do that.
Mental math, you don't. I didn't here. But let's make sure it works the same way. It's distribution of every term within this parentheses. A times the first term would be AB. Pick up your sign of addition. It's A times the next term, which is a negative term, a negative C. So that's going to be a negative AC. And then simplifying, that's AB minus AC. So make sure you're practicing with subtraction, that you can manage sign control. Distribution, we have A times the quantity B minus C. It's A times each term, and you can keep the sign of subtraction. Or work it out longhand, and you get the same answer. Okay, 2 times 3 minus 4 plus 2. Well, there's multiple operations going on. Multiple operations. I have multiplication and subtraction, a little bit of addition. So now I need to call on, please excuse my dear Aunt Sally. Who has precedence? How am I going to solve this? So parentheses, nope. Exponents, not this time. Multiplication and division. Multiplication from left to right. I'm going to multiply first. Multiplication, that's 2 times the next term. So the next thing I'm going to do is 6, copy everything else down the same. And I know that's going to be hard for you too, because we want to do mental math. I mean, we want to get to the answer, hope the answer falls to us from the bit bucket in the sky. But mistakes often happen when we skip a little too fast with mental math. So try to slow down. We are slowing down. This is a course meant to reestablish good habits and revisit topics that have been long forgotten or misunderstood or whatever, so that you can move on with your math career. All right, so we got multiplication. Division, I don't see any. Check that off. Addition. Here's addition. So let's add. 6 subtract 4 plus 2 is 4. Let's go addition or subtraction from left to right. It's from left to right, so what do you see first? Subtraction. It's not always addition, it's not always subtraction, it's from left to right. So as I move from left to right, it's either addition or subtraction. And what do I see first? Subtraction. 6 subtract 4 is, copy everything else down the same. Now what's left? Oh, there's still some subtraction. 6 subtract 4 is 2. What's left now? Oh, there's some addition from left to right. 2 plus 2 is 4. And I'm done. Okay. -2 to the 4th plus 51 times 4 minus 337 plus 23 times 2. So 37. -2 to the 4th plus 51 times 4. We're going to subtract that entire quantity. 37 plus 23 times 2. Well, we got a lot going on, so let's copy down. Please excuse my dear Aunt Sally. First, priorities, parentheses. I see parentheses. Within parentheses, I'm going to start at the top of my priority list again. Sometimes you can have nested parentheses, parentheses within parentheses. So we'll work on parentheses first. Within parentheses, I don't see any more parentheses. I don't see any exponents. From left to right, it looks like there's multiplication, so I'm going to do that first. And 23 times 2 is 46. I'm still working in parentheses. In my parentheses, looks like I can add next. Copy everything else down the same. 37 plus 46 is 783. It is a constant, so I can remove my parentheses. Next, there are no more parentheses, so I can check that off. Exponents. I have -2 to the 4th. So that's -2 to the 4th. Our exponents, 2 times 2 times 2 times 2 to the 4th. On our calculator, 2 2 raised to the 4th power, 16. Notice that it's still negative out here in front. This was negative 2, the base to the 4th. We recall that a negative 2 to the 4th, we'd have to prioritize the sign of the base. And a negative 2 times a negative 2 times a negative 2 times a negative 2 is still a positive 16. So multiplication and division from left to right. Oh, 51 times 4. 51 times 4. 204. Copy everything else down the same. Addition and subtraction from left to right.
I have a question.
Yes.
How do you make this 16? Shouldn't it be a positive 16 considering you're multiplying negative 8 by negative 2?
Considering what?
Considering you're multiplying a negative 8 by negative 2.
I'm not multiplying a negative 8 times a negative 2.
No, it's just 2 to the 4th.
Yes, I showed you here. This is our base. We carefully would isolate this if it were a negative base as negative 2 times a negative 2 times a negative 2 times a negative 2. It'd be 4 times a negative 2 be a negative 8, be a positive 16. My base is a positive 2 to the 4th. This is the same as negative 1 times 2 to the 4th. And I think that's where you're confused. So negative 1 times 2 to the 4th. It's not a negative base. Okay? So it's 2 to the 4th, and 2 to the 4th is 16. You agree with that? But it's the opposite. Times negative 1. 2 to the 4th is 16. It is not a negative base. If it were a negative base, we'd have to have the parentheses around the negative base. Good question, because it's a common mistake. And that's back to syntax, clarifying those parentheses. This is a clue, We have a negative base. Here, our base is positive 2.
So there was no negative base for 2. It was just 1 negative 2, right?
It's 2 to the 4th.
Yeah,
Yep.
add that negative 1.
It's actually, this is the opposite of 2 to the 4th, which is negative 1 times 2 to the 4th. So we got to deal with that negative separately.
All right.
So it is negative 16. And now we have negative 16 plus 204. Which is 188. Copy everything else down. And let's see. Looks like we can do some subtraction from left to right. 188 subtract 83.
105.
There you are. So yeah, there's quite a few things going on in this problem. Again, review pages 1 through 25. Order of precedence, a negative base versus the opposite of a base raised to an exponent. Well, with exponents, then we have to kind of take some care. Exponents, we're talking about a base raised to a power. A base raised to a power. So a base let's see. Let's go 6 squared. 6 is our base and our power is 2. This means the base times itself. How many times? The base times itself. How many times? That's
Twice.
a superscript, so it's up in the air. What'd you say?
Twice.
Twice. So 6 times 6. It's the base times itself 2 times, which is 36. 6 cubed. Our base is 6 raised to an exponent of 3. It's the base times itself. How many times? 6 times itself 3 times. Well, 6 raised to the 3rd power is 216. Now on my calculator, you have your exponent symbol. It's called the caret symbol. And it's 6 caret 3 on your calculator. So let's see, what's another example? 5 squared. 5 is our base. Our power indicates how many times we're going to multiply the base times itself. You know, exponents really is just a special case of multiplication. For multiplying, it's a special case of multiplication when your base is the same. So it's shortcut, shorthand for a special case of multiplication. Base 5 times itself twice is 25. 5 caret 2 on your calculator. And the reason why we have exponents is because what if I have 22 times itself 302 times? Well, that's 22 times 22 times 22 20 22 times. How would you like to pay me to solve this day after day after day? Is this how you'd want your employees to solve this problem? No, it's not how they solve these problems at NASA either. We have to have a shorthand or a shortcut. And we understand that it's multiplication, but it means the base times itself this many times. I don't think my calculator will do this one. Oh, there you go. It's only 19,758. Oh, 22 raised to the 302. Yeah, it's an overflow. It's a large number. But let's try 22 raised to the 30th. That's a large number using exponential notation, which you should know from chapter 2, I think. Let's just try something a little smaller yet. Raised to the 15. 22 raised to the 10. Yeah, that number gets large in a hurry. But 22 squared is 484. Well, then with exponents, we have special cases. Any base raised to the 1st degree is equal to the base itself. Any base raised to the 1st degree is equal to the base itself. Any base raised to the 0 power is equal to 1 by definition. So how am I going to remember that? Well, we know base 10 pretty well. 10 cubed is 10 times 10 times 10, which is 10 squared. I'm just reducing my exponent by 1. 10 times 10 is 100. I reduced by a power of 10, right? So 10 to the first, we would expect it to be 10. And 10 to the 0 power, 1. What about 10 to the negative 1? Think about our currency now. 1,000, 100, 10, a dollar bill. We take the base to the denominator and change the sign of the exponent. So that's 1 over 10, which is 1/10, which is in currency what? 0.10 is 10 cents. What about this? 10 to the negative 2. Take your base to the denominator and change the sign of the exponent, which is 1 over 100, which is 0.01, which is a penny. So kind of translating from this crib sheet, this is a good one, to currency, it'll help you apply these rules and special cases for exponents. So 7 squared would be 7 times 7, which is 7 to the first power, which we usually don't write. Your mic is on, by the way. 7 to the first power, we typically don't write the first power. We don't need to. We understand it's the first power. But 7 to the first power would be the base itself, right? 7 to the 0 power is 1 by definition. We talked about our commutative law yesterday. A times B equals B times C. A plus B equals B plus A. A plus B equals B plus A. We can have our terms switch their order. They can commute. So the order can change as long as it's all multiplication or as long as it's all addition. 3 times 4 is the same as 4 times 3. Some of our identity properties. Any number plus 0 is equal to 0 plus any number, which is equal to the number itself. Any number times 1 is equal to the commutative property for multiplication, 1 times any number, which is equal to the number itself. And we use these identity properties in solving equations. Then division, we have that one big special case that any number divided by 0 is undefined. Division by 0 is undefined. We cannot allow a denominator to take on the value of 0. Calculators will give you some type of a response. Error, division by 0. hopefully you'll get a reminder that division by 0 is undefined. But 0 divided by 5 is equal to what? 0. And reciprocals. Reciprocals. Given a number, say 7 again, its reciprocal is 1 over 7. Because a number times its reciprocal has to equal positive 1. So let's see, how about 15? If my number's 15, its reciprocal is 1 over 15. Reciprocals, I think I hear students say reciprocal, reflipical, flip it. Flip it. Because 15 times 1 over 15, that's 15 over 1, multiply numerators, 15 over 15. It's another name for positive 1. So that meets the definition. How about 2/3? The reciprocal of 2/3. Flip it. 2/3 times 3/2 would be 2 times 3 is 6. 3 times 2 is 6. That's another name for positive 1. So sure enough, that works. But how about something like a negative 2/3? I know you know reciprocals, we flip it, reciprocal, reflipical, but you have to tend to sign. And again, this is probably a case where you drop the sign or miss the sign. The reciprocal of negative 2/3 is, well, flip it. We get 3/2, and you keep the sign. Because a negative 2/3 times a negative 3/2, a negative times a negative is 2 times 3 is 6, 3 times 2 is 6, which is another name for positive 1. Your definition of a reciprocal is that a number times its reciprocal is equal to positive 1. So you have to be in control of the sign. So a negative 7/8, the reciprocal is
8 over 7.
8 over 7, negative. Because negative 7/8 times a negative 8/7, negative times a negative is positive. That's another name for positive 1, which is the definition of a reciprocal. So keep that in mind. Reciprocal, reflipical, but keep the sign. So 3 times the quantity 2n plus 1. This is our distributive property. We're going to distribute 3 times the first term, which would be 6n. Pick up your sign and distribute 3 times the next term, which is 3. Notice that on this side I have something times something. Something times everything within that parenthesis. On this side I have something plus something. This is my distributive property again. I have 3 times everything within this parentheses. So 3 times the first term would be 21x squared pick up your sign. 3 times the next term, 24x, pick up your sign, and 3 times the last term would be 15. Notice that this side of the equation I have something times something. On this side of the equation I have, what, 3 terms, and it looks like I'm adding those terms. But there's an equation with an equal sign. There's an equality going on. And 4 times the quantity, x minus 1. That's our distributive property. Again, I have 4 times something, 4 times every term within those parentheses. 4 times the first term would be 4x. Pick up your sign and distribute 4 times the next term, which is 4. This again, if you work it out longhand, we have 4 times x, change subtraction to addition and add the opposite. Four times the first term is 4x. Pick up your sign, and 4 times a negative 1 would be a negative 4, and we simplify that for x minus 4. Sometimes we have to work things out a little bit longhand to control properly the sign of our terms. And then the Pythagorean theorem. Says that if you have a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So if we have a right triangle means that you have a triangle with one interior angle of 90 degrees. And either the author will tell you that you're working with a 90-degree triangle, right angle, or they'll give a scenario that lends us to understand we're working with a right triangle in the story problem. So the Pythagorean theorem, we have a leg, and we call the longest leg the hypotenuse. And the Pythagorean theorem says that if you have a right triangle, side A squared plus side B squared is equal to side C squared. We have that relationship. So whatever the length of A is, square it. Whatever the length of B is, square it, and that would allow you to solve for C squared. So if we have an example where, leg A is, let leg A equal our, let's do it here. Leg A equals the height. Leg B, they tell us, is equal to 8 inches. And the hypotenuse is equal to 17 inches. So substituting leg B is 8 inches. C is 17, but we need to square it. 8 squared is 64. And 17 squared is 289. Now we're trying to solve for a goal of A equals, when we're solving equations, we're trying to solve for a variable A equals, not A squared. We have A squared, but if I try to isolate that term, I can use my addition principle and subtract the opposite. That'll go to 0. So I'll have A squared equals, but if I'm going to subtract 64 from this side, I have to subtract it from the other side as well. I'm using my addition principle. And 289 subtract 64. 250, 225. So A squared is equal to 225. We're solving for A. So the square root of 225. On your calculators, there's a square root symbol. 1, 2, 3, 4, fifth row, first column. Shift for the square root symbol. The square root of 225, close, 15. So I'm taking the square root of A squared. On one side of the equation, I'll take the square root of 225. On the other side, the square root of A squared is A. And the square root of 225 is 15. Let's see, for sure. 15 squared is 225, yeah. So the length of leg A is 15, and we were in inches. Solving. Length of an unknown side in a right triangle using the Pythagorean theorem. Okay, we'll see you tomorrow.